Welcome back to the Cable Data Science channel. It's the evening of Sunday, November 15th. I'm going to take a look at a package. Let's just take a look at YouTube first, okay? With all the publicity and all the talk and all the suits about voter fraud, you think there's got to be a better way to detect it, and there is. And that method is called uh, Benford's law. And as you can see, there's a number of different parts here. Okay, numerous articles on Benford all have to do with use it. This is sort of a basic tool of all types of what's called forensic analytics. And it's not only used for voter fraud, it's used for bank fraud, it's used for accounting fraud, all different ways it can be used for. Interesting enough, this one here is kind of interesting because according to this gentleman here, there is some irregularities in the voting numbers for Pennsylvania. But more interesting, he actually says there's voting irregularities on both sides. So he sees both voting irregularities, both Republican and Democrat in Pennsylvania, which probably isn't what you want to hear if you're a Republican right now. But anyway, more importantly, there is actually a pack. It should come as no surprise that there is a package. Uh, it should come as no surprise that there is an R package that deals with Benford's law. That package is benford.analysis package. Okay, so we're going to take a look at that package here. I've already installed it. The installation process is just coming over here and install Benford analysis. Interesting enough, there's also one called Benford test. So let's go and install that one also. I've already installed benford.analysis. We better install Benford test also, just to make sure we're covered here, all right? Okay. Now let's come back over here to GitHub, and we'll start with a general GitHub for Benford analysis. Repository. And we're going to create a new so I'm going to create a Benford analysis library. Uh, you know what? That's actually called Benford's law. Then we could use both of the Benford's law. Benford's dash Benford analysis. Okay. So we're going to start with a new project for R. As you noticed, I used GitHub. I would suggest if you haven't got a GitHub set up, you haven't got a GitHub um, account, set up a GitHub account and get in the habit of using GitHub to create your project libraries for all your R projects. Okay, as you can see, this is going to create so it's going to create a subdirectory benford-analysis under under R. You know what? Let's do. Let's come back up here and let's just change the name here real quick, okay? Benford's law analysis. Okay, there. Okay. See, what you saw, you just told me how to rename a package. Okay. Before we download, now we come over here, new project, version control, GitHub. Now we're going to put this here. Now it's going to create a subgroup called Benford's law analysis. Okay. Now we got a new project. Now I'm not going to guarantee you how far I'm going to go with this analysis, but we'll see. We'll see exactly what has to happen here. So let's just start out with a. Well, I always use Markdown, so it's Benford. Benford. Okay, let's just call this the Benford analysis package. Okay. Now, you know what? Let's also do dplyr. Okay. Benford analysis is the package. Okay. Okay. Benford. Benford analysis package. Okay. So it's named after the package here. Now, let's come over here, run this, then let's do Benford analysis. Okay, so here's Benford analysis for data validation and forensics. Okay, the Benford analysis package provides tools to make it easier to validate data using Benford laws. The main purpose of the package is to identify suspicious data that needs further validation. And the documentation. The main function is Benford. The package defines S3 methods for plotting and printing Benford type numbers. After running Benford, you can easily get the suspicious data by using the functions suspects table, get suspects, duplicates table, get duplicates. Okay? The package also includes 6 real data sets to illustrate the purposes. Okay. Now, data, appropriate places get data. Benford generates Benford objects. Okay. So let's just run these first plots here, okay? Now, basically what I'm going to do, I'm going to come here and probably just run through the, so let's just run this right off the bat here. Okay. Summation difference. Now, I don't understand what most of these things are for. So this is the first example here, okay? Let's take a look at the data. If we got some data to look at here. Corporate payments. What is this? Vendor number, date, invoice number, amount. Okay, so we can look through here. And all these should be data tables. Okay? So the first thing this does, it pulls the data. And this just gives us here vendor number, date, invoice number, amount. Now, if you look here, so this here is basically the corporate payments. Okay? Number of digits 2. Lines used, data used, data maintenance, data attribute. Benford. So this is data. Okay? This is BFD. So these are data table names. Hmm. So next it comes down here and it says, let's take a look at the head of head suspect tables. So let's come back down here then. Let's do a second number. Okay. So let's do this. Okay. So we're going to do this. Okay. So once again, let's do this. 1, 2, 3. Package. Okay. Okay. So let's just run this data right here first of all. Okay. Benford object. So it's going to come here. Data CP, print CP. Data corporate payment amounts. Number of observations 189,000. Number of objects for each for second order 65,000. First digits analyzed 2. Mantees. Quite honestly, I don't understand most of what this stuff is really talking about here. Okay. Remember, real data will never conform perfectly to the Benford's law. You should not focus on p-values. And now here you can see these plots here. Digits, uh, frequency, digits distribution, digits distribution second order. So I think this should be maybe 2 digits. Summation distribution by digits, chi-squared difference. Now we come down here and we look at the suspect table, CP, which is a suspect table. We're calling function suspect table. We're saying let's look at the first 10 things. Okay. Now, what does this mean? So it's the first digit's one, it occurs 50 times. 50 times. Number two includes okay. Now what do we do? Now gets observations of the two most suspicious groups. All right. And all I'm doing here is I'm just going through and I'm just running the okay. So now we get to suspects. Amos Moses. Sorry about that. I got distracted by something in the background there. Okay. 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 Well, I forgot about that. Okay. 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 So basically, all I'm doing, I'm simply just, I'm basically just I'm simply running the functions. Okay. Okay. So we're getting close. We're almost done. Now, honestly, I don't understand most of what these functions are doing right now, but that's why we got. Okay. Okay. So this is now at this point, I'm not so much concerned with understanding this data. Okay. And quite honestly, I'm not really qualified to. There. Okay. So let's just run this from the top and see exactly what we get here. Let's come to who's the author of this, by the way. Let's do this. Author. Okay, here we go. Because we have the title up here. Okay. So I just put the author's name down here. Okay. Now, quite honestly, I don't understand what most of this stuff is. Subject to object, corporate payments amount, number of observations used, number of observations for second order. I believe second order means, oh, I have to use 2 digits instead of just one. Now, what's mantis? I'm not really sure. Mean, variance, uh, the 5 largest deviations, digits 50. Okay, stats. Pearson's. So this is where this was the analysis here of Okay, well, let's take. Let's see if we can look at this. One other thing, if you come over here and you do this, maybe this. Okay. The one you're most common with is this here. Not sure what summation is, but you can see here digits 10, 24, 38. Okay, digits. Get suspicious observations of second most suspicious groups. Get observations of values with two or more duplicates. What does do? Duplicates. Let's run this again. Let's see something here. Press duplicates by decreasing order. Okay. Get the observations, duplicate tables. Print the duplicates by descending order. Get the observation of two values with more duplicates. Let's do this. Okay. So we get the observation of two values with the most duplicates. Get the mean absolute deviation. Chi test, Benson's Pearson test. Now, okay, so let's take a look at this last function down there. Get observations starting at 50 or 90. Date, vendor number. Okay. Unfortunately, he doesn't actually tell us what the answers are. Okay. 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 So this is where we wound up at. All right. Now, package census. Census 2019. Okay. Okay. So we come back up here. Data. Benford. Okay. Pretty simple stuff, done it. Data frame, field number, column number, obviously something here. Let's see what that. Data, number of digits is 2, sign is positive. Okay, so that's pretty simple. Okay, what she doesn't do, suspect table. Okay, data. Okay, we got back up here. Let's take a look at citizen. Okay, now let's take a look at census. Let's see, name, county, area, population 2000, population 2010. So it's pretty straightforward, apparently. Okay, so the data there is pretty straightforward. So let's do data again. Let's do taxable income. Oh, shoot. Control C. Okay, let's come back over here. Okay, so let's take a look here at taxable income. Okay, Taxable income, the 1972 income tax model. Formatted data frame with. I'm not quite sure what that represents. But anyway, you can see something here. But let's try this. Can we come back over here and pull out. Okay. What happens if you come back over here then? Takes the taxable income. Let's see. Let's see. Oh, you probably can't. So, okay. The question is this, can we now use. I did have dplyr up here, didn't I? Not that. There. Group by. Okay. So now, oops. Oh, jeez. Well, let's try two plots first of all. Okay. Okay, let's do this. Right? So, if this is correct, then what's the assumption here? Okay, so this is kind of interesting. Okay, sorry for my silence, but I can't think and talk at the same time. Now, is this a valid step in in uh, in well, the obvious way to test it would be to test it with a different set of data, right? So I took the data, taxable income 1978. I created a substring of just the first character. Okay? I then converted it to a data frame called FT. So then I take this and I do a count by the first digit. Okay? Then I plot the count. Okay? Now, could it really be that simple? What do you think? Do any of you have any experience with benford analysis? Okay, so it's kind of interesting. Um, but in theory, we should be able to come back up here and do the same thing. Okay? Okay, so no, so this anyway. So this is just the first look at the benford analysis package with my own little twist on the end here. Um, the question is, what are they doing with plotting the numbers above that? So we could, of course, take this and well, we could, in fact, duplicate this whole thing here down to here for the first two digits. Okay. All right. And then bring this down here. Okay. Come up here. Change this to this. Say, let's make this second digit. Change this to FD1. Change this to FD1. Second digit, right? Let's call this second income. Okay. Let's see if you can run this, see what happens. Variable data column. Oh, taxable income. Second digit. Group by first digit. Okay. First, produce the substring, second digit, then convert it into a data frame. Okay. And group by a field. No, not really. Okay. So let's do this step by step. First thing we're going to do is create the second digit field. Okay? Okay. Now we're going to convert the data frame. Then we're going to convert this into a data frame. Now, second digit, convert to data frame. Second income. Okay. Okay, so we're going to take FD1. Okay. Okay. So now we create a data frame called second income. Okay. Second income. Okay. So okay. Okay. Second digit count. Second digit. count. No, we don't. Oops, sorry. Okay. Not too sure about the second digit thing, about the second digit functions here. Uh, but it's just the idea that it's just, this again. This is intended to simply be a walkthrough for this package, and I hope it's maybe gives you a little something to think of, and also introduce you to the to how to do benefit analysis in R. There are numerous videos that show you how to do it manually without use of any packages. Well, this is one package here. I think there's actually a second package, which I'll look at a later date. Anyway, thanks so much for your time this evening. We'll catch you on the next report.